Communities in Australia and New Zealand have been using steel-reinforced concrete pipe for almost 100 years for stormwater drainage, gravity sewers and irrigation purposes. As we progress into the 21st century, some of that early pipeline infrastructure is in need of replacement. Not because of the structural integrity of the concrete pipes, but because of the increased hydraulic capacity required of a pipeline network in today's society. The reason steel-reinforced concrete pipes are so durable is that they're built to last and are virtually synonymous with sustainable development, meeting the needs of the community now without compromising the needs of future generations. Steel-reinforced concrete pipes meet the design criteria of conduit, structure and durability for any pipeline. Over the course of time, other materials have been tested and used for pipeline systems. How do these other material types compare with reinforced concrete for use in stormwater, culvert and gravity sewer pipelines? Pipes are classified as either rigid or flexible. Steel-reinforced concrete pipe is naturally considered a rigid material. Typical flexible pipes are constructed using materials such as corrugated metal, high-density polypropylene, PVC and glass-reinforced polymers. So how do these flexible pipes meet the design criteria of conduit, structure and durability? Both reinforced concrete pipes and flexible pipes pass the score as hydraulic conduits, provided that they maintain their shape. To do this, they must maintain the original parameters put in place by the pipeline designer, and this places a high importance on the load-carrying capacity of the structure over time. Structurally, flexible pipes can't carry applied loads on their own. In fact, the load-carrying capacity of flexible pipes can be as little as 1%, but is more commonly 5 to 15% depending on the materials used. Under direct load, they deflect and assume an oval cross-section. The applied load is then shed into the backfill. This backfill and surrounding soil must maintain sufficient long-term strength to protect the viability and dependability of the pipeline. Steel-reinforced concrete pipes, however, as rigid structures, are able to carry 85 to 95% of any load applied to the pipeline and use the surrounding soil to improve their load-carrying capacity. AS/NZS 2566.1, Structural Design of Buried Flexible Pipes, and AS/NZS 2566.2, Installation of Buried Flexible Pipes, require the pipeline bedding and surrounding material to be compacted within strict specification and controlled guidelines. This ensures that the soil achieves a predetermined density before a load is applied, without deflecting the flexible pipe beyond predetermined limits outlined in the standard. If the compaction of the surrounding soil is not controlled, the pipe will deflect over time. This will affect the structural efficiency and the hydraulic capacity of the pipe, thus affecting its performance. If a pipe deflects and exceeds the limits in the standard, then the structure is deemed to have failed. Traditionally, pipelines have been inspected manually, provided they were large enough, or a calibrated proving tool has been used. Limitations in these methods have seen advances in technology and the introduction of the closed-circuit television camera, or CCTV unit. CCTV has allowed asset managers to gain a more in-depth analysis of pipeline systems. Today, further advances in technology allow a laser profiler to be mounted on a CCTV unit measuring ovality or changes in pipe profile. This delivers the asset manager a qualitative visual survey of the pipe, as well as a quantitative measurement of the changes in profile, in particular deflection rates. This is important in flexible plastic pipe, as deflection measurements should be taken at the time of installation and at 12 months, when the surrounding soil has had time to settle and long-term consolidation has taken place. It's also prudent for asset managers to continue checking the profile of their pipe asset over time, as deflection can increase over a number of years. Designers need to ask themselves a question when considering the type of pipe to be used in a system. How long is that pipe required to last? Steel reinforced concrete pipe, because of the unique manufacturing process involved, along with the typical nature of concrete materials, will get stronger with age. Using the Australian and New Zealand standards AS-NZS 4058 precast concrete pipe and AS-NZS 3725 designed for installation of buried concrete pipes, pipes can be expected to last in excess of 100 years. The strength of flexible plastic pipes, however, goes in the opposite direction. At the time of manufacture, plastic is at its maximum strength. Thereafter, as flexible plastic pipe is loaded, deflection will increase as a function of time, and this is without additional load being applied. This is why strict limits on maximum allowable deflection at installation and over time are nominated by Australian and New Zealand standards. Flexible metal pipes, such as steel corrugated pipe or aluminium pipe, work in a similar manner. These products are also susceptible to corrosion, particularly over a long period of time. Remember, pipes are used to transport water. Pipelines are important structures that must be designed and installed to specific engineering requirements. The structural performance and in-service life of a pipeline is dependent on achieving the specified design and installation requirements appropriate to the selected pipe material and the available site conditions. With 100 years' experience and design and installation criteria that makes it suitable to the harshest environments, it's hard to go past steel reinforced concrete pipe.